I've got a job coming up where I'm going to have to tap about 50 M1.6 holes. Now, this is a normal tap set. This goes down to M3. That's just a little bit bigger than a 256 tap. This is a tap set that covers M2.5 all the way down to M1. Now that's the M3 tap, and that's the M1.6 tap, and it is absolutely tiny. So there are two things that I want to make my job easier. One is a tapping guide. That's something that I can slide in that will hold it vertical so that I'm not going to break the tap, and a little knob to give me a feel rather than using a big tap wrench on such a tiny little tap. Now, tap guide is very simple. It's just a piece of metal with a hole in it, which is about the size of the tap, so that the tap can slot down, rotate freely, but not rock about side to side too much. To make it easier to hold on to, because it's such a small diameter, I've decided to make a sort of top hat shape with a larger disc to put my fingers on and a smaller collar to support the tap. And that's very similar to an idea that I've got for my CNC milling machine. I want to make tool holders like this, kind of like the TTS system for Tormach machines. This would be a good tap guide for an M10 if it was slightly larger. But for the CNC mill, I want to make 16mm diameter top hats like this with holes of different size. They will need to be very accurate, because what I want to do is shrink fit them. So heat them up, drop the tool in like that, and then let it cool down, and the holder shrinks down onto the tool and holds it firmly. I can then fit them into a collet, so I just have the one collet in the mill, and then all the tools have got the same fitment, and that means that I can record the lengths of all the tools, and I don't have to measure the tool every single time. So that's a project for another day. What I'm going to prove out is feeds and speeds for machining steel on my little CNC lathe, so that I can, turn these out, because I'm going to have to make quite a few for all the different tools for the CNC machine. So it'd be nice to be able to just hit a button, tweak a value for the bore, and have a tool holder come off the machine. I'm going to open the file, which is M1.6 tap guide profile. I will make sure that the material is stuck out far enough. I've zeroed my Z on the work. Let's make a tap guide. So at the moment I haven't got anything set up to drill holes particularly well on this lathe, so I'm just using the tailstock, and I'll just have to manually drill them. And the tailstock needs a lever because it's currently got a nut that you have to do up, which is a bit of a pain, because when it's in the right position it collides with the cross slide like that. To get underneath. There we go. So I'm going to manually turn the spindle on, which for the purposes of this 750 RPM will do. So I'm drilling with a 1.7mm drill for a 1.6mm tap. I tried the 1.6 drill, it was too close, you effectively had to thread the tap in, so going for a little bit of clearance. Now the fairly terrifying bit where we're going to parts it off. our rather hot tap thingy. So I'm thinking of doing a bunch of these, different sizes for all my different taps, just for hand tapping. And I thought it would be good to stamp on the size. So make sure I've got these in the right order. M1 and 6. So I'm going to do 3D printed this guide to get the spacing sensible. M1.6, just about readable. There we are. Just sharpied it and wiped it off. That'll do. I'll work on that. So I've got a tap guide, got a tap. Now I just need a little knurled knob. Now the only appropriately sized aluminium I've got is this long bar, so we'll just have to put this in. Not gonna fit. Oh, it doesn't fit. So the bore in my lathe is 25.4. This bar is slightly oversized, which, you know, fair enough. Got more metal for my money, but doesn't fit down the spindle bore. So this tap body is 2.1 thereabouts. So I'll try 2.1. If not, I'll open out with 2.2. Pad, and out to the mill to cross drill and thread that. Just going to put some paper around it to protect it in the vise. I think I'll go, I don't know, with one of them. That looks about perfect actually. So tap in place, nip it up. There we are. We have sensitive tapping handle. Alright, let's see this thing in action. Now this is the kind of material well, it's about the thickness of material I'm going to be tapping. Here's our tap guide. We actually need to get the tip of the tap in the hole. We can then hold that down with our fingers, and I can just carefully now, I won't be using this particular tap for the job that I'm going to be doing. I'm going to get a better quality one. This is probably the worst quality tap you could have, but actually that's made using a tap that tiny slightly less stressful. And this design of tap guide is a lot easier than I made this one for an M2.5, just for a one-off or a couple of holes that I needed to do, but holding that wasn't very easy, so definitely having that to put a couple of fingers on is an improvement for such a small thing. I suppose I should put a screw in it to just demonstrate. Blimey. There we go. Right, so now I've got the tools I need to do a little job, which make my life a fair bit easier. And I've also managed to dial in the machine so that I can run off the tool holders for my CNC mill. Hope you enjoyed that, and thank you for watching. Some fig chips off that.